Alright, let's get started. Today we're looking at Kafka Downstream Replication with MySQL and Kafka topic consumers during the process. Our setup today is 3 databases. They are not running MySQL Replication. They're all 3 separate standalone databases running on Raspberry Pi with MySQL InnoDB, with our source database DB1 and our downstream standalone databases DB2 and DB3. We have 4 screens in our demonstration. Screen 1 is the source database, where we'll run our insert, update, deletes on some data, and downstream is our database DB2 on screen 2 and DB3 on screen 4. Screen 3 is a monitoring of the heartbeat information from the Kafka consumer. So here we are, we've got our 3 session terminals on the servers for our databases and one for logging. And what the main interest, if you listened to the previous video, was showing our demonstration of the herbT demonstration. That herbT demonstration helps us to create a herbT. Today, in this episode, we're going to look at the behind the scenes of what's actually happening with our database. So we'll just log in and get our information about our sessions. So you can see here we're logged in host 1, host 2, host 3. This is the Pi database. These are the Kafka downstream database schemas that receive the changes that the database users in those environments will see however they want to see it, whether it's reviews or ETL or some other form of information. Down the bottom here is our log. We're going to look at the injector log. This is on node 2. This is the standard output from the consumer of Kafka that's actually doing the transmission of the database changes for us. You can be any log you want. We're just putting in this location today. So if we have a quick look, we can see every 5 seconds there's an update to the log, which is showing that there is some transactions coming through. So we can see here it's saying insert into this table here called Kafka JSON capture, and the information is database and table type. The action type is insert, and the data is here. We've got the KID, which is the Kafka ID, and the host name. This is just a heartbeat, goes every 5 seconds to keep our Maxwell daemon running and transmitting to Kafka on timely fashion. So we'll have a look at the background of the tables. We don't really need to see node 3. I'll give you a quick look at node 3 to show that they're the same. So if we want to look at the Kafka schema and see what's inside it, we can have a look and see that there's quite a lot of information about the different types of objects. We've got some triggers here, and triggering when there are inserts. So the trigger here is a trigger type of insert, where there's a row, and after the row is inserted it does something. If we go down, we can see there's some base tables to handle our capturing information. So here's all the trigger names that we have in place, and here are the tables. The 2 tables are herbs and herbT. They're the final destinations of the data that we're going to change today. The Kafka ins we just saw before is the heartbeat table. The main table is the JSON capture table. That receives the transactions from the Kafka consumer, and it's the staging table. It has the triggers on this table. If it's an insert, update or delete, it then inserts a row into the below tables. If it's a herb, like in our demonstration, it'll go into the herbs insert, update, delete table. If it's a herbT insert, it'll go into the herbT versions of those tables. So we'll just have a quick look down here, and we can see that the same information is also down the bottom in our bottom tables. So we've got the same information as well in our node 3. So I'm going to hide that for now and minimize it. We'll just focus on node 2 so we get a bit more screen space. We'll have a look at our tables for pi. We've got two tables. Like we did in our previous demonstration, we have our herb T table. We've got some herbs in there. There's quite a lot of rows in there. We looked at different types of herbs and different benefits they have. So I like to drink a lot of herb tea, so I make my own tea. So I was feeling a little bit anxious before, so I wanted to make an anxiety tea, so there's a benefit of anxiety. We then went and listed all the teas that have a benefit of anxiety, and this is one of their benefits. We found 4 of them. So we then decided we're going to insert those rows into our herb tea table so we can make a herb tea from these 4 herbs. So to do that, before we do that, I want to look at the underlying tables. So I've got a little script here that shows me some basic information about our Kafka tables on our downstream. So here we can see we've got a database table called Kafka ins. It's got 144. If we run it again, it should pump up to 145. So we can see our inserts are running on our injector down here. I'm not particularly interested in keeping the injector log running for all the changes, so I'm going to just filter out things related to herb for our demonstration. So that should have nothing there now. So we can see here that in our table there is an empty data set. These are the empty sets of the tables that we just saw before. On node 3 we can see that there are these tables here. So we've got the capture tables. These are these lines here. So I'm going to go ahead and run an insert now. I'm going to insert some data into our source table from our herbs. We want to find anything that's got a benefit of anxiety. So we insert, we can see Kafka's fired off. It's picked up the changes on a table called herb teas. There's an insert statement. Here's the data. If we select star from our herb teas table, we can see there's some rows there. Likewise, if we come over to our downstream, we can see that there's now some rows there. Now, what does this all mean? How does it actually get to these tables? We just look at our injection script. So it's, instead of having this section empty now, it's telling me that the injector table or the Kafka capture table for the inserts on the herb teas table has received these transactions. So it's got 4 inserts, and we can then have a look at that like we did in our previous demonstration. We wanted to update the value of the T type to new, from new to something a bit more useful. So we wanted to say it's an anxiety T. So we run some updates. Here's our updates down here. And let's just run our injection report again, and we can see now we've got some updates in there as well. So that's all fine and dandy. The thing that's of interest is what do these tables look like? So the main table, the staging table, is the capture table. So if we describe our capture table, we can see that our capture table has the format of the first column being JSON, with the remaining columns being virtually generated, and they're generated using the DocType standard, or doc type standard for JSON, and it interpolates this information from here and turns it into human readable values down here. So if I did a select star from this table, so if you do select star from our capture table, and we probably want to limit it so where the table type equals herb tea, and that'll bring back some rows. There's a lot of stuff there, so I'll clean this up. I'll put it into 2 separate, so I'll just grab the doc first. So I'll grab doc. These are the actual JSON that's transmitted via Kafka and inserted into our first column of our table. So our JSON is the first column, this is the doc column, so you can see there's a transaction coming through, and this one is for a insert on herb teas. And down the bottom here we can see the format's changed a bit, and it's now got an update. So we got an update on our herb teas table as of the type, this type. Now you can also see here there's another new section in the JSON called old. So that's the old column value for t-type was new. It's saying this is the old value, and I want to update that so that the table, the t-type, is now anxiety. So that's how the JSON is formatted. And so if we then wanted to look at the rest of the data, what it actually looks like, we can have a look at the actual human readable columns. So the table is JSON capture. We want to do a select distinct from there on the database table and type columns that's in that table. So here's the human readable format of that. So we've got Kafka, here's our table called ins, our heartbeat, and we've got two tables here where there's been some inserts and updates on our herb teas received, and this is telling us the information regarding those particular transactions. I'll describe this, and let's just take the group by away and put aware the table equals to herb teas, and we'll get rid of our distinct, and we'll put in there the actual data, and make our screen a bit bigger. And so there we go. Now we can see our capture table has received some inserts, and the JSON for that insert is insert an ID of 99, the dose, the herb, the t-type, the serving size. And down the bottom here we can see that there's been some updates, and it's telling us that there's the same sort of information about the actual row to be updated. So that's how we're getting the information. And then we said, well, we've got these remaining tables that actually show information and handle how we process our final information. So the insert table, capture table, that's the downstream from the capture table for herb teas, has the extra data that's being replicated. So if we want to translate that into human readable format, we need to select the extrapolated columns, these virtual columns down here, to see what's actually being created from these JSON statements that we received above. So let's go ahead and have a look at the data ID, the dose, the herb serving type, and data serving size inside our herb teas insert table, and we're going to order it by the data ID to give it some consistency. So we've got 4 rows. We can see that the data ID here matches the data ID down in our up in our original source database. So that pretty much is the same for all the tables that we have. We can have a look at the update table, and you can see there's some similar information. So I'm going to delete now from our herb teas to clear out the table on the source, and hopefully we can see the transactions coming through and being replicated downstream. So if I now go to the delete table, let me just have a look at deletes and see what's in the delete table. There's 4 delete records as well, saying delete these from our tables. So if we go back and we source our inject script that tells us what's going on, we can see that we now have 4 deletes here and now have been recorded, and we've got 4 inserts, we've got 4 delete updates, and we've now got 4 deletes in our tables. If we select star from herb_teas, you'll find there's no rows in our herb tea table. So that is the background of how we're getting the JSON captured and how it works with replication. Thanks very much for listening.